All right, guys, we're going to go over the review sheet today. So the first ones we have are determinants. Any questions on 1 through 4, finding the determinant of a matrix? We feel good with these here? Because for the most part, we plug it into the calculator, let it do it for us. That's true with 1 through 4. Now, for 5 through 6, use Kramer's rule to solve the equations. Now, for this here, especially on the test, one of the things I do want you to do is set them up. So for number 5, we are going to solve for x, and we're going to solve for y. So we are going to have two fractions. We'll have a determinant on top, determinant on bottom. Top, bottom. Now you could go on and just skip to having what it's equal to. That's just fine. Now the determinant of the denominator of both these here is just the coefficients of our variables. So here's going to be 2, -3, 4, 5. 2, -3, 4, 5. Now since we're solving for x first, we're going to replace the two x values, 2 and 4, with what the equations are equal to. So here's going to be 8, -6. We want -3 and 5. For the y values, we're going to replace the y values, numbers that are in front of the y's, with what it's equal to. And we get this here. Now at this point, we can take the calculator and let it do it for us. Edit A to 2 by 2. 8, -3, -6, 5. 8, 3, -6, 5. Second quit. Second matrix. This time we can do matrix B and say another 2 by 2. So 2, 8, 4, -6. 2, 8, 4, -6. Second quit. Second matrix. C is a 2 by 2. 2, -3, 4, 5. 2, -3, 4, 5. Now we could take the determinant of each one of these here. So determinant of matrix A, let's see that it is 22. So the numerator of this here is 22. And I can say second matrix determinant, second matrix B. I see that it's -44. And then lastly, find the determinant of the denominator, C, which is 22. So both of these here would indeed be 22, telling us that the first one, 22 over 22, is 1, and the second one is -2. Or, in the calculator, we can go second matrix determinant, second matrix A, over second matrix determinant, second matrix C, and it tells us that it is indeed 1. Then we can go back in and replace A with matrix B and get -2. So our solution is the point 1, -2. Questions on this here? Now for certain on the test, I do want the setup for each of the variables. So here, since it's just two variables, we do want the setup for x, the setup for y, and what they are equal to. So we need all of that. Questions on this here? Questions on number 6? We good with number 6? So 6 is essentially the same thing, but instead of having two variables, we would have 3. Questions on finding the inverse of a matrix. You need to see finding one of the inverses. No? Because again, with any of these here, we can plug them into the calculator and let it do it for us. If it does give us an invalid dimension, or not invalid dimension, but singular, that means it doesn't have an inverse, and it works out that the determinant is 0, because if the determinant is 0, it does not have an inverse. So if we feel good with these here, we can move on. And especially on the test, if you are finding inverses, please put them as fractions, not as decimals. Convert them to fractions. And I know number 12 had some very not pleasant fractions as an answer. Questions on 13 or 14? Because 13, 14, or really 13 through 17, for us to add or subtract, the dimensions of the two matrices have to be the same. For us to multiply or divide or multiply, the columns of the first has to match the rows of the second. But again, with any of these here, we can type them into the calculator, let it do it for us. So we feel good with any of these operations, any of these that you want to see done. And really with all these here, especially on the test, something like this here, I would go in and plug in, if you're going to do it in the calculator, this is A, this is B, this is C, this is D, and this one has E, and then just call up what it exactly calls for. Oh, didn't actually need that. So we have 18 and 19. Determine which ones are the solutions. Determine if each of the following points are solutions to the system. So this here is just looking for a yes or no. So for the first one, 0, 4. So I can plug in 4 times 0 minus 7 times negative 4 is equal to 28. And at this point here, I can type this entire left-hand side into the calculator. So 4 times 0 minus 7 times negative 4 is 28. So we do get 28 is equal to 28. So that works. Now we have to have it for both. So negative 0 plus 2 times negative 4 is equal to 12. Well, that's 0. Well, negative 8 is not equal to 12, so this is no. Because the point, whatever the solution is, has to work for both, or in 19's case, all three. Because if it doesn't work for all the equations, it is not a solution. For it to be a solution of the system, it has to work for every equation. Any other questions on 18? Now 18, it ended up being that none of A, B, C, and D, none of the 4 points worked. And that's mainly because of a typo for this one here. Because if we actually had flipped it and said 4 times 140 minus 7 times 76 is equal to 28. 4 times 140 minus 7 times 76. Make sure. 4 times 140 minus 7 times. Yes. Parentheses, minus 7 times 76 is 28. And negative 140 minus plus 2 times 76, we get 12. So incidentally, the point 140 comma 76 actually does work. I had it flipped. Any other questions on 18? Questions on 19? Just plug them in and see which one works for all three. If it doesn't work. And if it doesn't work for one, you don't have to try the rest. Or Once it doesn't work for one of the equations, you don't have to keep trying it for the rest of them. Questions on 20 or 21? One of these that we want to look at. So it says solve by any method. So we can do the inverse method, where A inverse is just the inverse of the matrix of this here, and B is just our matrix of what it's equal to. We can do REF of our matrix, or we can use Cramer's rule, or we can solve by elimination. We can use any of these methods to solve. We just have to pick one of them. Well, looking at 21, the first equation has 3 variables, the second has 2, and the last has 1. So I'm going to start off, 3z is equal to -6. Well, to find the value of z, I divide both sides by 3. Telling us z is equal to -2. Now I'm going to go to the second equation that has y and z and plug z in for it. 5 times -2 is -10. At this point here, we can add 10 to both sides, telling us y is 5. -5x plus 3y plus 6z is equal to 4. Well, at this point, we don't know what x is, so we still have 5x plus 3, well, y is 5, plus 6 times z, z is -2, is equal to 4. Plus 15. Really, at this point, we're just solving it out. 3 times 5 is 15. 6 times -2 is -12. 15 minus 12 is 3. Divide both sides by -5. And x is -1/5. So our solution for this here is -1/5, comma 5, comma -2. And that's it. Questions on this here? And I mean, we could have done this by RREF. Second matrix, edit 3 by 4 is what it was at -5. 3, 6, 4, 0, 1, 0, 0, 3. Second matrix. RREF, second matrix A. We get this here, and if we go math, enter, we see that the solution set is -1/5, 5, -2. We could do the same thing for the first one. We can grab the calculator, go second matrix, over to edit. It's still 3 by 4, but this time we have quit. Then we can do the same thing. RREF matrix A, and we get this here, so 0, 0, negative 3. Any questions on any of these here? Questions on 22 or 23? But even if it does fraction, we can still do RREF. But instead of a 3 by 4, these are a 2 by 3. So we go with 22 and 23. Questions on 24 and 25. Well, we have 2 factors of this denominator, and each one of them is degree 1. So that just means the numerators for our 2 fractions are going to be A and B. At this point here, we're going to multiply everything by both fractions. Everything's going to cancel on the left-hand side, leaving us with 3x plus 10 is equal to, here, 2x plus 3 and 2x plus 3 cancel, leaving us with A times x minus 4, plus B times, well, the x minus 4 and x minus 4 cancel, leaving us with 2x plus 3. If we distribute, A times x is ax. A times negative 4 is negative 4a. Plus b times 2x is 2bx. And b times 3 is plus 3b. Now we need to match up our terms. 3x is going to match up with our ax and 2bx, so we have 3 is equal to a plus 2b. We can drop the x because we don't really need it. We just need the a and b because 3 technically had x, so did a, so did b. So we're just looking at the numbers. Now the other is matching up our 10 with our negative 4a plus 3b. Now at this point here, we don't have a single variable by itself, which is nice, but it does mean we need to get one of the variables to be the same. Well, we can get a to be the same, and to do that, we need to multiply the other equation by 4. 4 times 3 is 12. 4 times a is 4a, and 4 times 2b is 8b. Now we can add these two together. 10 plus 22, or 10 plus 12 is indeed 22, is equal to negative 4a plus 4a is 0, and 3b plus 8 is 11b. At this point here, we can divide both sides by 11, telling us b is 1. Now at this point here, I just need to pick an equation to use. I'll use our original equation. 3 is equal to a plus 2b. B is 2, thank you. I don't know why I put 1. That should be 2, thank you. Yeah. That would have thrown everything off. You'd probably be staring at your answer key later wondering why it was so different. Luckily, a is indeed -1. Which tells us that we have -1 over 2x plus 3 plus 2 over x minus 4 is our final answer. Questions on this here? Questions on 24 or 25? Do we want to look at 25? Well, 25 has 3 factors because we have x minus 2, and x minus 2 squared. Since the degree of each one is technically 1, because even though the last one has parentheses squared, it's still just a single term. Now we're going to multiply everything by the denominator of what we started with, so x times x minus 2 squared. For the first one here, everything cancels, leaving us with 2x squared minus 8 is equal to a, well, x and x cancels, leaving us with x minus 2 squared, plus one of the x minus 2's will cancel, telling us that we have bx times x minus 2, plus x minus 2 squared cancels, leaving us with cx. Now our x minus 2 is going to be multiplied by itself, and we'll work that out here in a minute. Now the bx, we can distribute it through bx times x is going to be bx squared. Bx times -2 is -2bx plus cx. Now we can distribute this here, giving us x squared minus 2x plus 4 plus bx squared minus 2bx plus cx. Squared minus 4x plus 4 and lastly we can distribute the a, giving us ax squared minus 4ax plus 4a plus bx squared minus 2bx plus cx. At this point here, we do need to match up our terms. So 2x squared is going to match up with our ax squared and bx squared. They're telling us that 2 is equal to a plus b. Now we don't have an x term, so its value is understood to be 0, because we have 0x, since it wasn't included. Now this will match up with our -4ax, so -4a, -2bx, and plus c. And lastly, our constant term, -8. Well, the only thing that hasn't been used is 4a. So -8 is equal to 4a. We're going to solve from here. Well, I can solve a first by dividing both sides by 4, telling us a is -2. Now we can plug it into the first one, telling us 2 is equal to -2 plus b. This point here we can add 2 to both sides, telling us b is 4. Yep. And last but not least, we could plug it in to solve for c. So 0 is equal to negative 4 times negative 2 minus 2 times 4 plus c. Well, negative 2 times negative 4 is 8. 2 times 4 is 8 plus c. Well, that just tells us 0 is equal to c. So A is negative 2, B is 4, and C is 0. So this here is our final answer, or we can just say negative 2 over x plus 4 over x minus 2. Because 0 over x minus 2 squared is just 0. Questions on any of this here? We good with this here? Find the solution for the systems of nonlinear equations.